So last class we did 5 problems like that. So now move to the 6th one. So 6th one is determinant of a minus b minus c 2a 2a 2b b minus c minus a 2b 2c 2c c minus a minus b will be equal to a plus b plus c whole cube. Okay, so last class we did some of the problems on this right there. So you know the elementary operations also how you can apply. Solution, let us take on the LHS. LHS equals to determinant of a minus b minus c 2a 2a 2b b minus c minus a 2b 2c 2c c minus a minus b. So this is LHS. So in the first row 2 elements are same, in the second row 2 elements are same, in the third row 2 elements are same. So obviously you can apply the elementary operation as R1 changes to R1 plus R2 plus R3. Okay, that equals to, you know how to add the rows right there. So this is R1 plus R2 plus R3. A minus B minus C plus 2B plus 2C. A minus B minus C plus 2B plus 2C. Next R1 plus R2 plus R3. 2A plus B minus C minus A plus 2C. R1 plus R2 plus R3. So 2A plus 2B plus C minus A minus B. So this is R1. What about R2? R2 and R3 as it is. 2B, B minus C minus A, 2B, 2C, 2C, C minus A minus B. So now simplify here. A minus B plus 2B, B. 2B minus B is B right there. 2C minus C is C. So you get A plus B plus C. Same. 2A minus A is A. Just B. 2C minus C is plus C. Similarly that also 2A minus A is A. 2B minus B is plus B. Next plus C. This is the R1. R2 and R3 as it is. 2B, B minus C minus A, 2B. 2C, 2C, C minus A minus B. So what we can take on? Taking common factor A plus B plus C from R1. From the first row, you took A plus B plus as a common. So if you took A plus B plus as a common, what is remaining in the first row? You took all as a common factor. So 1, 1, 1. Next, the second row. 2B, B minus C minus A, 2B. Next, 2C, 2C, C minus A minus B. So this is the remaining after taking A plus B plus as a common from the R. Okay, if you apply R1 changes to, so what is the elementary operation you can apply? C2 changes to C2 minus C1, comma, C3 changes to C3 minus C1. This is the elementary operation you can apply. So that equals to, so A plus B plus C will be as it is. Now, what is the column 1? Column 1 as it is. So 1, 2B, 2C. What is the column 2? Column 2 can be taken as column 2 minus column y. You can subtract that. So this column minus this column. Column 2 minus column 1. Similarly, column 3 minus column 1. From this column also you can subtract this column. So 1 minus 1 is 0. B minus C minus A minus 2B. So means B minus C minus A minus 2B. So B minus 2B is minus B right here. So minus A minus B minus C. So minus A minus B minus C. So this minus this. So 2C minus 2C is 0. Next, column 3 minus also column 1. 1 minus 1 is 0. Then 2b minus 2b, that is also equals to 0. Next, c minus a minus b minus 2c. c minus a minus b minus 2c is c minus 2c minus c. So again we'll get minus a minus b minus c. Okay, now see above the diagonal elements, all are zeros, right? So what you can do, you can multiply the principal diagonal elements. So that equals to a plus b plus c into 1 into. So in this you can take a minus as a common, means a plus b plus c. Again in this also you can take minus as a common, means a plus b plus c. So this minus into minus becomes plus. A plus b plus into 1 is a plus b plus c. So multiplying 1, 2, 3, total 3 times means so a plus b plus c whole cube. So that is the RHS. So this is the required answer. Got it? So applying that, R1 changes to R1 plus R2 plus R3 and adding the corresponding elements of R1, R2 and R3 after taking the common factor as a plus b plus c from the R1 and remaining. If it is applying R1 changes to R1 plus R2 plus R3, so it is obviously common. So C2 changes to C2 minus C1, C3 changes to C3 minus C1. Afterwards, above the principal all are zeros means you can multiply the principal diagonal elements. In these 3 minus will be common, in these 3 also minus will be common. So minus into minus becomes plus, a plus b plus c into a plus b plus c into a plus b plus c is a plus b plus c whole cube, that is an RHS. Okay, next one. Seventh one. Determinant of x plus y plus 2z, x y, z y plus z plus 2x y, z x z plus x plus 2y will be equals to 2 times of x plus y plus z whole cube. So the next one, take on the LHS. Determinant of x plus y plus 2z and x and y. Z y plus z plus 2x y. Z x z plus x plus 2y. So here in the column 2 elements are same, column 2 elements are same, column 3 2 elements are same. We can apply the elementary operation as column 1 changes to column 1 plus column 2 plus column 3. Okay. So now what is column 1 plus column 2 plus column 3? You can add this plus this plus this. You are adding left and right elements, right? So that's why it is a columns. X plus y plus z plus x plus y. If you add this plus x to here, this plus y to here, it becomes 2x plus 2y. Otherwise, first write x plus y plus 2z plus x plus y. Column 1 plus column 2 plus column 3. Next, z plus y plus z plus 2x plus y. Column 1 plus column 2 plus column 3. Z plus x plus z plus x plus 2y. column 1, column 2, column 3. Next x, y plus z plus 2x, x, y, z plus x plus 2y. So this is the column 3. Now, so just simplify here. X plus x is 2x, y plus y is 2y plus 2 times of z. Same next also 2x, y plus y 2y, z plus z is 2z. 2x plus 2y plus 2z. Same x plus x 2x, 2y, z plus z is 2z. 2x plus 2y plus 2z. Column 3, column 2, column 3 as it is. X, y plus z plus 2x and x, y, z plus x plus 2y. So now in this step, taking common factor. So in this entire term also you can take 2 as a common factor. So 2 times of x plus y plus z from which row, which column? From column 1. So entire column 1 you took this as a common. So that comes as outside. So 2 times of x plus y plus z will be the common. What is remaining in the column 1? So entire you get column right. So 1, 1, 1 is the column 1 because you took this as a common from the column 1. Second column is x, y plus z plus 2x and x, y, z plus x plus 2y. So now, if it is column 1 changes to column 1 plus column 2 plus column 3, so then what we can apply here? We can apply R2 changes to R2 minus R1, comma, R3 changes to R3 minus R1. Okay, so that equals to 2 times of x plus y plus z. So write the R1 as it is 1 x y. It is R1. R2 can be taken as R2 minus R1, right? So this minus this, this minus this, this minus this. This is R2 minus R1. 1 minus 1, 0. So if you subtract this minus this means y plus z plus 2x minus x. This minus this 2x minus x is x, right? You will get x plus y plus z. These two as it is 2x minus x, you will get x. Next y minus y is 0. Next R3 also changes to R3 minus R1. This minus this R3 minus R1. This minus this and this minus this. 1 minus 1, 0. X minus x is 0. Z plus x plus 2y minus y. What is 2y minus y is y, right? So that also can be written as x plus y plus z. So now, so observe the principal diagonal elements. So below the principal diagonal elements all are zero space. We can multiply the principal diagonal elements. So 2 into x plus y plus z into 1 into x plus y plus z into again x plus y plus z. So 1 time, 2 times, 3 times. So it should be whole cube, right? So 2 times of x plus y plus z whole cube. So that should be the RHS. So this is how you can prove the problems. So by using the rows and by using the columns. Got it? Next one. So once again you can work out these problems. Otherwise you will not get the problems properly in the properties of determinants. Okay. So next 8th question. Determinant of a square plus 1 AB AC AB B square plus 1 BC CA CB C square plus 1 will be equals to 1 plus A square plus B square plus C square. So okay, next one. So first write LHS, afterwards we see which elementary operation we can apply. So LHS equals to determinant of a square plus 1 AB AC AB B square plus 1 BC. So CA CB C square plus 1. Okay. So what is on the right hand side? It is 1 plus A square plus B square plus C square, right? See, enter any row or enter any column. If you add rows or columns, will you get 1 plus A square plus B square? No. Here 1 plus A square is there, right? In this entire window or enter in this column, there is no B square and C square. For that, what I am taking means multiply R1 by A, R2 by B, comma R3 by C, and divided by ABC. I will apply this condition here. So divide by ABC means that can be written as an outside. So 1 upon ABC. Now for R1 you can multiply by A. For entire R1 you can multiply by A, right? A square into 1 is with A into A square plus 1. A into AB is A square B. A into AC is A square C. For entire R2 you are multiplied by B. So B into AB is AB square. Then B into B square plus 1. B into BC is B square C. For entire R3 you multiply by C. C into CA. So AC square. C into CB. BC square. Next C into C square plus 1. So this is the term you got. Now, so once again, I will take the common. Taking common factor A from column 1, B from column 2, C from column 3. From the column 1, from the column 2, from the column 3, I take that ABC as a common. So now it becomes 1 upon ABC, it is as it is. What is not taken as common? A, B is right. A from column 1, B from column 2, C from column 3. In the first column, we can leave A. We can leave A here, A square plus 1. We can leave A here, B square. We can leave A here, it is C square. In the second column, we can leave B from column 2. If you leave that B, it is A square. If you leave B, B square plus 1. If you leave B, C square. From the column 3, you took C as a common. You can leave C enter column 3. A square, B square, and C square plus 1. So now this ABC gets cancelled. Okay. Now in this step, see, in the row 1, 2 elements are same, 2 elements are same, 2 elements are same. So I can apply the elementary operation as R1 changes to R1 plus R2 plus R3. So adding R1 plus R2 plus R3. This element plus this element, this plus this plus this plus this plus this. That is R1 changes to R1 plus R2 plus R3. Okay. Now R1 plus R2 plus R3. A square plus 1 plus B square plus C square. I can write that as 1 plus A square plus B square plus C square. Again, this plus this plus this. A square plus B square plus 1 plus C square, because all are adding right there. So again this can be write as 1 plus A square plus B square plus C square. Next, A square plus B square plus C square plus 1. So that also can be write as 1 plus A square plus B square plus C square. Okay. Now it is in R1. What about R2? So B square plus 1 B square. Next C square plus 1. Same once again. Taking common factor right. You got that entire R1 as that 1 plus A square plus B square plus C square as a common. Taking common factor 1 plus A square plus B square plus C square. From which row? From the row 1. So that can be written as the outside. So 1 plus A square plus B square plus C square. What is remaining in the R1? 1, 1, 1. R2 B square b square plus 1 b square, c square c square c square plus 1. So if it is R1, what is the one more elementary operation you can apply? So C2 changes to C2 minus C1, comma C3 changes to C3 minus C1. So this column minus this column minus this column. So column 1 should be as it is 1 plus a square plus b square plus c square. Column 1 is 1 b square c square. Column 2 minus column 1. So this column minus this column. 1 minus 1 0. b square plus 1 minus b square. b square plus 1 minus b square is plus b square minus b square getting cancelled, we get 1. c square minus c square 0. Column 3 minus column 1. 1 minus 1 0. b square minus b square, that is also 0. c square plus 1 minus c square. c square plus 1 minus c square plus c square minus c square gets cancelled, again also you get 1. So again, above the principal diagonal elements, all are zeros, right? You can multiply the principal diagonal elements. So 1 plus a square plus b square plus c square into 1 into 1 into 1, that equals to 1 plus a square plus b square plus c square. That should be the RHS. Correct? But here starting, so why I multiplied for this means to make that entire row, entire column as in terms of squares. So that's why I took R1 multiplying by R1 by A, R2 by B, R3 by C. Once you can multiply means you can divide by that element. You are multiplying R1 by A, right? So you can divide with A. R2 by B means divide B with B. R3 by C means divide by with C. If it is common, there is no problem. So why you are multiplying dividing means if you again apply the elementary operation means the determinant will not change. So that's why to multiply, obviously you can divide. To multiply, obviously you can divide. You can multiply, so obviously you can divide that element. Okay. So this is how you can apply the elementary operations. Got it? See? Next one. So next nice question. Determinant of 1 plus A 1 1 1 1 plus B 1 1 1 1 plus C will be equals to ABC into 1 plus 1 by A plus 1 by B plus 1 by C, that equals to ABC plus BC plus CA plus AB. Okay, you can prove those two, but in exam they will not give those two. Any one they will give to prove. Okay, so for that also you can prove the entire problem only. So this continuation is this only. Okay, don't worry in the problem. So same like here, first take the LHS. Determinant of 1 plus A 1 1 1 1 plus B 1 1 1 1 plus C. Now see here, in this problem R1 has two same elements, R2 has two same elements, R3 also has a two same elements. Column 1 is also 2 same, column 2 also and column 3 also. So either you can apply R1 or you can apply C1. But if you apply R1 here, let's see. Okay. But actually you cannot apply first. First let's see whether you will get the answer or not. R1 plus R2 plus R3. What is this R1? R1 plus R2 plus R3, right? 1 plus A plus 1 plus 1. 1 plus 1 to 2 plus 1 is 3 plus A. R1 plus R2 plus R3. 1 plus 1 plus 1 is 3 with plus B. 1 plus 1 plus 1 is 3 plus C. If we can take any as a common, so no, right? It's not possible to take. So that's why you cannot apply R1 changes to R1 plus R2 plus R3 here. Okay. So now what we can apply means, see on the right hand side, you want 1 by A, 1 by B, 1 by C, right? In this problem, any you are like this, like 1 by A, 1 by B, 1 by C, no, right? If you taking a common factor A from R1, B from R2, C from R3. Let's see whether you get 1 by A, 1 by B, 1 by C or not. A, B, C as a common from R1, R2 and R3, so you get A, B, C. In the first row, what is the common you are taking? A, right? In this one, you took A as a common, you will get 1 by A. In this A, you took A as a common, you will get 1. C. So you have 1 plus A. In these two terms, if you take A as a common, in this one is there any A term? No, right? So for that, you can write this term as 1 by A. Again, A into 1 by A, getting cancelled, you will get 1. And this A, you can take A as a common, means you will get 1. So that A, I took already as a common, and what is remaining term is 1 by A plus 1. For this one, if you took A as a common, it is 1 by A, so it is also 1 by A. Similarly, in the second row, what are taking common? B, right? So it becomes 1 by B, it becomes 1 by B plus 1, and it becomes 1 by B. Next, similarly, R3. So if you took C as a common, right? So that remains is 1 by C and 1 by C and 1 by C plus 1. Okay, so this is the terms you got. Is that elements are present in the RHS, right? So obviously, now we can apply that elementary operation as R1 because R1 2 elements are same, R2 2 elements are same, R3 3 elements are same. So you can apply the elementary operation as R1 changes to R1 plus R2 plus R3. So A, B, C. So R1 plus R2 plus R3. So this plus this plus this. 1 by A plus 1 plus 1 by B plus 1 by C can be written as 1 plus 1 by A plus 1 by B plus 1 by C. Same, this plus this plus this. Again, this can be rewritten as 1 plus 1 by A plus 1 by B plus 1 by C. 1 by A plus 1 by B plus 1 by C. Again, these three elements add 1 by A plus 1 by B plus 1 by C plus 1. I can rewrite as 1 plus 1 by A plus 1 by B plus 1 by C. Again, all are same. Nothing will change here. Okay. What about R2 and R3? So there as it is because we are applying only R1 but not R2 and R3. So what is R2? 1 by B. 1 by B plus 1. 1 by B. 1 by C. 1 by C. 1 by C plus 1. Okay. Obviously what you took as common. So taking common factor. Which one? 1 plus 1 by A plus 1 by B plus 1 by C from R1. Sorry, the remaining already ABC is there. So with that ABC into 1 plus 1 by A plus 1 by B plus 1 by C will be the common from the R1. So in the entire R1 that is a common, right? And after it as a common, remaining is 1, 1, 1. From the second row and third row as it is 1 by B, 1 by B plus 1, 1 by B. 1 by C, 1 by C, 1 by C plus 1. Okay. So now, which elementary operation you can apply? Already I told, right? If R1 changes to R1 plus R2 plus R3, so you can apply C2 changes to C2 minus C1 and C3 changes to C3 minus C1. So that equals to ABC into 1 plus 1 by A plus 1 by B plus 1 by C. So this column minus this column, same this column minus this column. So 1 by B, 1 by C as it is. Column 2 minus column 1, right? 1 minus 1, 0. 1 by B plus 1 minus 1 by B. So 1 by B plus 1 minus 1 by B, right? Column 2 minus column 1 alwa. 1 by b minus 1 by b getting cancelled, we will get 1. 1 by c minus 1 by c, 0. Column 3 minus column 1, 1 minus 1, 0. 1 by b minus 1 by b, 0. 1 by c plus 1 minus 1 by c, same. 1 by c plus 1 minus 1 by c plus 1 by c minus 1 by c gets cancelled, we get 1. Check here, above the diagonal elements all are zeros right there. So you can multiply the principal diagonal elements. So a, b, c into 1 plus 1 by a plus 1 by b plus 1 by c into 1 into 1 into 1. That's 1 into 1 into 1 is as it is right there. A, b, c into 1 plus 1 by a plus 1 by b plus 1 by c. So you got this one. So for this one, just multiply a, b, c into 1, a, b, c. A, b, c into 1 by a gets cancelled, b, c. A, b, c into 1 by b, b gets cancelled, a, c. A, b, c into 1 by c, c, c gets cancelled, we will get a, b. So that should be the RHS. Okay, this is how you can solve the problem. Okay, so see that one. Next one. The 10th one, determinant of 1 x square 1 x square 1 will be equal to 1 minus x cube whole square. Okay, see the next one. Write the LHS. 1 x square 1 x square 1. Okay. Now 1 minus x cube you want to write on the right hand side. Now see here. So there is no R1 common elements, R2 common elements, R3 common elements. So for that on the right hand side what it is there, according to that you can apply the elementary operation. So R1 is 1 minus, you can subtract, so this element. So for this element we can multiply by x. So now x into x square become x cube right there. We will get 1 minus x cube right there. So 1 minus x into x square is x cube. For that I am applying the elementary operation as R1 changes to R1 minus x R2. Similarly apply for these two rows. So this is in R2 minus this is in R3. For this you can multiply with x. So x times of R3. So you can apply along R2. Okay, now see what we will get. So R1 changes to R1 minus x R2. So first row minus x times of this row 1 minus x into x square is x cube. Next R1 is x minus x into R2 is x into 1, x into 1 is x. Again R1 is x square minus x into R2, R2 is x into x is again you will get x square. This is R1 changes to R1 minus x R2. Similarly R2 changes to R2 minus x R2 right. So now for this row and this row minus x times of this row. So now it becomes x square R2 minus x into R3. R3 is x, right? X into x is x square. Now R2 is 1 minus x times of R3. R3 is x square. X into x square is x cube. Again R2 is x minus x times of R3 is 1. X into 1 is again x only. Now what about R3? That is as it is. So x square 1. Now x minus x gets cancelled. X square minus x square cancelled. X square minus x square and x minus x gets cancelled. So what is remaining? Determinant of 1 minus x cube 0 0. Now 0 1 minus x cube 0 x square 1. Now above the principal diagonal elements, again all are zeros, right? You can multiply the principal diagonal elements. So that equals to 1 minus x cube into 1 minus x cube into 1. So 1 minus x cube into 1 minus x cube is so 1 minus x cube whole square. So that should be the RHS. Got it? See. Determinant of 1 plus a square minus b square 2ab minus 2. 2ab 1 minus a square plus b square 2a. 2b minus 2a. So 1 minus a square minus b square. So will be equal to, so 1 plus a square plus b square whole cube. So now take LHS. LHS equals to determinant of 1 plus a square minus b square 2ab minus 2b. 2ab 1 minus a square plus b square 2b. 2b minus 2a 1 minus a square minus b square. Okay. So now what you want? So you want 1 plus a square plus b square 3 times, right? So for that, okay, see here. So this is 1 plus a square but minus b square is there. But what you want? Plus b square, right? For this minus b square, if you add 2b square, so minus b square plus 2b square is b square, right? For this, is there any 2b square here? So there is no. So for that, so for this one and this one, see correctly, for this one it is as it is R1. For this I will multiply b. It is in third order, right? B into R3, that is 2b. B into 2b, 2b square. So 2b square minus b square. You can this minus, and if you add this term means, so this is minus b square plus this is b into 2b, 2b square. So 2b square minus b square becomes b square, right? So you can apply the elementary operation as R1 changes to R1 plus BR. Now, similarly, for this 2, okay, this is in R2, so this is in R3, so this is minus a square. If you multiply a to the R3 element, what it becomes? A into minus 2a minus 2a square. But here minus a square, here minus 2a square. Again, if you add this, it becomes minus 3a square. For that, if for this you can multiply minus means, so minus a into minus 2a. plus 2a square. Again 2a square minus a square is again a square only, right? So obviously we will get the term 1 plus a square plus b square. So for that r2 changes to r2 minus a times of r3. Okay, see the problem. So see properly, r1 plus br3. So this row plus this row. So which one? So this r1 and r3. So next this r2 and r3. So for second row, this row and this row. For the r1, this row plus this row. So first this element and this element, r1 is 1 plus a square minus b square plus b times of r3. So b into 2b is 2b square. Next this one and this one. So 2ab. For this we multiply with b later. b into minus 2a minus 2ab. For this and this, so it is minus 2b. For this one multiply with b later. b into 1 is plus b na? Okay, plus b times of 1 minus a square minus b square. Okay, so plus b times of r3, b into this entire term. So r1 changes to r1 plus br3 completed. Now r2 changes to r2 minus a times of r3. What is this r2? r2 is 2ab minus a times of this one. Minus a into 2b. It's minus 2a. Now these two. 1 minus a square plus b square minus a into minus 2a plus 2a square. So this one and this one. 2a minus a into this one is minus a into 1 minus a square minus b square. So got it? What about r3? As it is. So 2b minus 2a. So 1 minus a square minus b square. So got it? Now simplify here. So 1 plus a square minus b square plus 2b square is b square. Or 2b square minus b square is b square. 2ab minus 2ab gets cancelled, 0. Now in these two, we want plus a square plus b square, right? But here minus a square minus b square is there, right? So for that, you took here b is there, here b is there. So b as a common, because you want here plus, right? So minus b as a common. If you took minus b as a common, what is remaining here? 2. Then, so all the terms here, the terms will change. Because we have took minus b as a common, right? Now plus 1 becomes minus 1, minus a square becomes plus a square, minus b square becomes plus b square. Otherwise, you can multiply once. Minus b into 2, minus 2b, minus b into minus 1, that is b into 1 plus b, minus b into plus into minus minus, a square into b, again minus into plus minus, b square into b cube, b into b square is b cube. Okay, similar. So now this 2ab minus 2ab gets cancelled, we get 0, and 1, 2a square minus a square is it is a square plus b square. So again in these two terms also just take a as a common, that's it, because already in front of this term minus is there, you can multiply it, so always it becomes plus. So in this a gets cancelled common, here remaining 2, minus into 1 minus 1, minus into minus is plus a square and plus b square. So next 2b, next minus 2a, next 1 minus a square minus b square. So got this right? 2 minus 1, 1, again 2 minus 1, 1. So write the remaining term. So that equals to determinant of 1 plus a square plus b square. So 0. So minus b common, what is remaining? 2 minus 1 is 1, right? So 1 plus a square plus b square. So see here, why I took that minus b as a common means, because to want that 1 plus a square plus b square, for that only I took that minus as a common. Here there is no minus common, because in front of this already minus is there. If you multiply this minus becomes obviously it is plus, that's why there is no minus is common then. Okay, next 0, 1 plus a square plus b square. So already a there one. 2 minus 1, 1 plus a square plus b square. So next, what is the last row? 2b minus 2a, 1 minus a square minus b square. Okay. So ಮತ್ತೆ ಈಗ ಏನು ಕಾಮನ್ ಈಗ 1 plus a square plus b square ಇಲ್ಲಿ 1 plus a square b square ಇದೆ ಕಾಮನ್ ತಗೋಬಹುದು from r1 so ಇದರಲ್ಲಿ ಕಾಮನ್ ಇದೆ from r2 so taking common factor ಯಾವುದು 1 plus a square plus b square from ಎಲ್ಲಿಂದ from r1 and r2 ಹಾಗಾದ್ರೆ ಎರಡರಿಂದ ಕಾಮನ್ ತಾನೆ so whole square ಬರುತ್ತೆ so that equals to 1 plus a square plus b square whole square so whole square ತಾನೆ ಯಾಕಂದ್ರೆ ತಗೊಂಡಿರೋದು 1 plus a square plus b square ಕಾಮನ್ from ಎರಡು rows ಇಂದ so first row ಇಂದ ಕಾಮನ್ ಬಂದಿದೆ second row ಇಂದ ಕಾಮನ್ ಇದೆ so you can take it as a 2 times as a whole square so ಏನು ಮಿಕ್ಕಿದೆ 1 plus a square b ಕಾಮನ್ ಹೋಯ್ತಲ್ವಾ 1 ಇಲ್ಲಿ 0 ಇಲ್ಲಿ minus b ಅಷ್ಟೇ so ಇಲ್ಲಿ 1 plus ಕಾಮನ್ ಹೋಯ್ತಲ್ಲ 0 ಕಾಮನ್ ಹೋಯ್ತು 1 ಇದರಲ್ಲಿ ಕಾಮನ್ ಹೋಯ್ತು ಮಿಕ್ಕಿರೋದು a so next 2b minus 2a so 1 minus a square minus b square okay so whole cube alva ಇನ್ನೊಂದು ಬರಬೇಕು ತಾನೆ so ನಾವು ಇಲ್ಲಿ ಲಿಮಿಟ್ ಆಪರೇಷನ್ ಅಪ್ಲೈ ಮಾಡಕ ಆಗಲ್ಲ so just expand along the row okay so that equals to 1 plus a square plus b square whole square into for the one we can leave the first row first column 1 into this one means 1 minus a square minus b square minus a into minus 2a minus 2a square minus 2 alva so it becomes plus 2a square okay note first correct again for 1 here we can leave the first row first column 1 into this one is this one minus a into minus 2a minus 2a square alone minus is the plus side next minus ಅದನ್ನ ನಾವು ಏನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತೀವಿ 0 ಯಾಕಂದ್ರೆ ನಾವು 0 ಗೆ ಏನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತೀವಿ 0 ಅಲ್ಲ ಅದಕ್ಕೆ ನಾವು ಬಿಟ್ಟಿದ್ದೀವಿ ಸೊ ಪ್ಲಸ್ into minus minus b first row third column ಬಿಟ್ಬಿಡಿ 0 into minus 2a 0 minus 1 into 2b so 2b ಆಯ್ತು ಅಷ್ಟೇ so that equals to so 1 plus a square plus b square whole square ಅಲ್ವಾ so 2a square a square ಅಂದ್ರೆ a square ರಿಮೈನಿಂಗ್ ಎರಡು ಹಂಗೆ ಇರುತ್ತೆ ಇದಕ್ಕೆ ನಾವು 1 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ಸೇಮ್ ಟರ್ಮ್ ಬರುತ್ತೆ so 1 into 1 is 1 minus a square plus 2a square is plus a square and remaining minus b square 0 into 0 you can leave minus b into 0 0 ಅದನ್ನು ಬಿಟ್ಬಿಡಿ minus b into minus so minus minus is plus 2b square ಆಗಿದೆ 2b square b square ಆದ್ರೆ b square ಅಷ್ಟೇ ತಾನೆ so equals to 1 plus a square plus b square whole square into 1 plus a square 2b square and b square ಆದ್ರೆ b square so multiply ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ whole cube ಆಗುತ್ತೆ so 1 plus a square plus b square whole cube ಯಾಕಂದ್ರೆ power 2 ಇಲ್ಲ power 3 ಆಯ್ತು so that should be the RHS okay so correct ಆಗಿ ಅದನ್ನ ನೋಡ್ಕೊಳ್ಳಿ okay so next question So 12th question. So determinant of minus a square ab ac ba minus b square bc ca cd minus c square will be equal to 4 times of a square b square c square. So you see the solution? LHS. So determinant of minus a square ab ac ba minus b square bc ca cb minus c square. ಇಲ್ಲೆಲ್ಲ ನಾವು ಅಪ್ಲೈ ಮಾಡೋಕ್ಕಿಂತ ನಮಗೆ a square b square ಬರಬೇಕು ತಾನೆ. ನೋಡಿ ಸಿಂಪಲ್ ಆಗಿ r1 ಎಲ್ಲದರಲ್ಲಿ a ಇದೆ, r2 ಎಲ್ಲದರಲ್ಲಿ b ಇದೆ, r3 ಎಲ್ಲದರಲ್ಲಿ c ಇದೆ. ಕಾಮನ್ ತಗೊಂಡ್ಬಿಡಿ. ಸೊ ಟೇಕಿಂಗ್ ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್ ಯಾವ್ದು? a ಫ್ರಮ್ r1 ಮತ್ತೆ b ಫ್ರಮ್ r2 ಮತ್ತೆ c ಫ್ರಮ್ r3. ಸೊ ನಮಗೆ ಏನು ಕಾಮನ್ ಬಂತು? ನಮಗೆ ಸೊ a b c ಕಾಮನ್ ಬಂತು. ಎಲ್ಲಿಂದ? r1 ಇಂದ a. ಸೊ a ಹೋದ್ರೆ ಮೈನಸ್ a, ಇಲ್ಲಿ a ಹೋದ್ರೆ b, ಇಲ್ಲಿ a ಹೋದ್ರೆ c. r2 ಇಂದ b ಕಾಮನ್. ಸೊ b ಹೋದ್ರೆ a, ಸೊ ಒಂದು b ಹೋದ್ರೆ ಮೈನಸ್ b, ಒಂದು b ಹೋದ್ರೆ c. ನೆಕ್ಸ್ಟ್ ಇದರಿಂದ c ಕಾಮನ್. c a ನಲ್ಲಿ c ಹೋದ್ರೆ a, c b ನಲ್ಲಿ c ಹೋದ್ರೆ b, ಮೈನಸ್ c ಸ್ಕ್ವೇರ್ ಒಂದು c ಹೋದ್ರೆ ಇಟ್ಸ್ ಮೈನಸ್ c. ನೋಡಿ ಮತ್ತೆ ಕಾಮನ್ ತಗೋಬಹುದು. a b a ಕಾಮನ್ ಫ್ರಮ್ ಕಾಲಮ್ 1, b ಕಾಮನ್ ಫ್ರಮ್ ಕಾಲಮ್ 2, c ಫ್ರಮ್ ಕಾಲಮ್ 2. ಮತ್ತೆ ಕಾಮನ್ ತಗೋಬಹುದು. ಟೇಕಿಂಗ್ ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್ a ಫ್ರಮ್ ಕಾಲಮ್ 1 ಮತ್ತೆ b ಫ್ರಮ್ ಕಾಲಮ್ 2 ಮತ್ತೆ c ಫ್ರಮ್ ಕಾಲಮ್ 3. ಸೊ ಹಾಗಾದ್ರೆ ಏನಾಗ್ತದೆ? ಸೊ a b c ಇಂಟು ಇನ್ನೊಂದು a b c. ಯಾಕಂದ್ರೆ ಆಲ್ರೆಡಿ a b c ಇದೆ, ಇಲ್ಲಿ ಮತ್ತೆ ಕಾಮನ್ ಬರ್ತಾರೆ a b c. a ಇಂದ ಕಾಲಮ್ 1 ಎಂಟೈರ್ ಕಾಲಮ್ ಅಲ್ಲಿ a ಬಿಟ್ಬಿಡಿ. ಸೊ ಈಗ ಏನಾಗುತ್ತೆ? ಮೈನಸ್ 1 1 1. ಎಂಟೈರ್ ಕಾಲಮ್ ಇಂದ b ಬಿಟ್ಬಿಡಿ. 1 ಮೈನಸ್ 1 1. ಎಂಟೈರ್ ಕಾಲಮ್ 3 ಇಂದ c ಬಿಟ್ಬಿಡಿ. 1 1 ಮೈನಸ್ 1. ಸೊ a b c a ಸ್ಕ್ವೇರ್ b ಸ್ಕ್ವೇರ್ c ಸ್ಕ್ವೇರ್ ಆಗ್ತಾನೆ. ಇನ್ನು ಎಷ್ಟು ನಂಬರ್ ಬೇಕು? 4 ಬರಬೇಕು. ಅದಕ್ಕೆ ಇಲ್ಲಿ ಏನೋ ಒಂದು ಎಲಿಮೆಂಟರಿ ಆಪರೇಷನ್ ಅಪ್ಲೈ ಮಾಡೋಣ. ಸೊ ನೋಡಿ 1 ಮೈನಸ್ 1 ಇದನ್ನ ಮಾಡ್ಬಿಟ್ಟು 0 ಆಗುತ್ತಾ? 1 ಪ್ಲಸ್ 1 2 ಏನೋ ಬರುತ್ತೆ. ಸೊ ಹಾಗಾದ್ರೆ ನಾನು ಏನು ಅಪ್ಲೈ ಮಾಡ್ತೀನಿ? r1 changes to, so just r1 ಮತ್ತೆ r2 ಮಾತ್ರ ಆಡ್ ಮಾಡ್ತೀನಿ. ಯಾವ್ದನ್ನ? r1 plus r2 that equals to abc into abc is a square b square c square. Okay, r1 can be changed as r1 plus r2, right? Minus 1 plus 1 0, 1 minus 1 0, 1 plus 1 2. According to the elementary operation r1 plus r2. ಈ ಎರಡು r2 ಹಂಗೆ ಇರುತ್ತೆ. 1 minus 1 1 1 1 minus 1. ಸಿನ್ಸ್ ಆಗ್ಬಿಡಿ, ಯಾಕಂದ್ರೆ ಆಲ್ರೆಡಿ ಎರಡು ಜೀರೋಸ್ ಬಂದಿಲ್ವಾ, ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಮಾಡ್ಬಿಡ, ಸಿಂಪಲ್ ಆಗಿ ಬಂದ್ಬಿಡುತ್ತೆ. ಸೊ ಪ್ಲಸ್ ಮೈನಸ್ ಪ್ಲಸ್ ಎಕ್ಸ್ಪ್ಯಾಂಡಿಂಗ್ ಅಲಾಂಗ್ r1. ಹೌದಾ? a ಸ್ಕ್ವೇರ್ b ಸ್ಕ್ವೇರ್ c ಸ್ಕ್ವೇರ್. ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಏನು? 0 ಗೆ. ನಾವು 0 ಗೆ ಏನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ 0 ನೇ. ನೆಕ್ಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಏನು? ಮೈನಸ್ 0. ಅದಕ್ಕೆ ನಾವು ಏನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ 0 ನೇ. ನೆಕ್ಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಏನು? ಪ್ಲಸ್ 2. ಇದಕ್ಕೆ ಏನು ಮಾಡಬೇಕು? ಯು ಕ್ಯಾನ್ ಲೀವ್ ದ ಫಸ್ಟ್ ರೋ ಥರ್ಡ್ ಕಾಲಮ್. 1 into 1 is 1, minus 1 into minus 1 is minus 1. ಇಲ್ಲ minus 1 ಏನಾಯ್ತು? ಪ್ಲಸ್ 1 ಆಯ್ತು. 0 ಬಿಟ್ಬಿಡಿ, 0 ಬಿಟ್ಬಿಡಿ. 1 plus 1 ಎಷ್ಟಾಗುತ್ತೆ? 2. 2 into ಎಷ್ಟಾಯ್ತು? 4. So 4 times of a square b square c square. That should be the RHS. Got it? So that's the answer. Okay, next one. So 13th one. Same, prove that all problems have determinant of b plus c. A b c plus a b c a plus b will be equals to 4 times of abc. So same see the LHS here. Determinant of B plus C A B C plus A B C A plus B. Okay na? So ನಮಗೆ ಇಲ್ಲಿ ಬರಬೇಕಾಗಿರೋದು 4 times of ABC. ನಮಗೆ ಇಲ್ಲಿ ಎಲ್ಲಾದ್ರೂ A B C ಕಾಮನ್ ಬರುತ್ತಾ? ಸೊ ಬರಲ್ಲ. ಸೊ ಇಲ್ಲಿ ನೋಡಿ ಎರಡು ಕಾಮನ್ ಇದೆ. ಇಲ್ಲಿ ಎರಡು ಸೇಮ್ ಎಲಿಮೆಂಟ್ಸ್ ಇದೆ. R2 ನಲ್ಲಿ ಎರಡು ಸೇಮ್ ಎಲಿಮೆಂಟ್ಸ್ ಇದೆ. R2 ನಲ್ಲಿ ಎರಡು ಸೇಮ್ ಎಲಿಮೆಂಟ್ ಬಟ್ ಆಡ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ ನಮಗೆ ಟರ್ಮ್ಸ್ ಆಡ್ ಆಗುತ್ತೆ. ಬಟ್ ಇಲ್ಲಿ ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮೀನ್ಸ್ ಇಲ್ಲಿ ಮಲ್ಟಿಪ್ಲೈ ಆಗೋ ಚಾನ್ಸ್ ಇಲ್ಲ. ಅದಕ್ಕೆ ಏನು ಮಾಡ್ತೀನಿ ನಾನು ಏನಾದರೂ ಒಂದು ಎಲಿಮಿನೇಟ್ ಮಾಡಿಕೊಂಡು 0 ಮಾಡೋದು ನೋಡ್ಕೊಳ್ತೀನಿ. ಸೊ ಅದಕ್ಕೆ ಏನು ಮಾಡ್ತೀನಿ ನೋಡಿ ಇದಿದೆಯಾ B plus A ಎರಡು ಆಡ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ B plus C. ಸೊ ಇದರಿಂದ ಮೈನಸ್ ಮಾಡಿದಾಗ ನಮಗೆ 0 ಬರುತ್ತಾನೆ. ಸೊ ಅದಕ್ಕೆ ನಾವೇನು ಅಪ್ಲೈ ಮಾಡ್ಬೋದು R1 changes to R1 ಹಂಗಿರುತ್ತೆ. ಈ R2 ಮತ್ತೆ R3 ನ ಆಡ್ ಮಾಡಿ ಏನ್ ಮಾಡಬೇಕು R1 ಅಲ್ಲಿ ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕು. ಸೊ ದಿಸ್ minus sum of these two minus B plus is B plus C B plus minus B plus C ಆಗುತ್ತಲ್ವಾ. ಸೊ ಅಪ್ಲೈ ಮಾಡಿ ಏನು ಬರುತ್ತೆ ನೋಡೋಣ. ಸೊ R1 changes to R1 minus of R2 plus R3. ಸೊ R1 ಏನು B plus C ನ minus of R2 plus R3 B plus C. Next R1 ಬಂದು A minus of R2 plus R3 C plus A plus C. Next again R1 ಏನು A minus of R2 plus R3 B plus of A plus B. ಕರೆಕ್ಟಾ? R2 ಡಾಟ್ ಹಂಗೆ ಬರ್ಕೊಳ್ಳಿ. ಸೊ B C plus A B C A plus B. So B plus C minus B plus C cancel ಆಯ್ತಾ? A minus into A minus A but ಇಲ್ಲಿ ಪ್ಲಸ್ A cancel ಆಗಿಲ್ಲ ಮೈನಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ವಿ minus into A minus A minus A 0 ಆಯ್ತು. C plus C 2C minus 2C A minus into A minus A ಸೊ ಅದು ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು ಕರೆನಾ. ಸೊ ಏನು ಮಿಕ್ಕಿದೆ ನೋಡಿ ಇಲ್ಲಿ ಏನಾಯ್ತು 0 C plus C 2C with minus 2C B plus B 2B with minus so minus 2B ಆಯ್ತು. So next what is remaining B C plus A B ಮತ್ತೆ C A plus B. ಸೊ ನಾವು ಬೇಕಂದ್ರೆ ಇದನ್ನ ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ಬೋದು. ಮತ್ತೆ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಸ್ವಲ್ಪ ಮತ್ತೆ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ನಾವು ಇದಕ್ಕೆ 2 times ಮಲ್ಟಿಪ್ಲೈ ಮಾಡೋಕ್ಕಿಂತ ಇಲ್ಲಿ 2C plus 2A ಇಲ್ಲ ಮತ್ತೆ ಮೈನಸ್ ಮಾಡೋದು ಅಲ್ಲಿ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಬೇಕಂದ್ರೆ ಹಂಗೂ ಮಾಡ್ಕೋಬಹುದು. ಸೊ ಇಲ್ಲೇನಿದೆ B ಇದೆ ಇಲ್ಲೇನಿದೆ minus 2B ಇದೆ. ಸೊ ನಾವು ಇದಕ್ಕೆ ಎಷ್ಟು ಮಾಡಬೇಕು 2 times ಮಾಡಿ ಇದಕ್ಕೆ ಆಡ್ ಮಾಡಬೇಕು. ಸೊ ಹಾಗಾದ್ರೆ R2 changes to ಎಷ್ಟು ಟೈಮ್ಸ್ R2 ಎಷ್ಟು ಟೈಮ್ಸ್ ಇದಕ್ಕೆ 2 times ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕು. ಸೊ R2 ಅಂದ್ರೆ B into 2 ಏನಾಯ್ತು 2B ಈ 2B ಇದಕ್ಕೆ ಏನು ಮಾಡಬೇಕು ಆಲ್ರೆಡಿ ಮೈನಸ್ ಇದೆ ತಾನೆ. ಸೊ ನಾವು ಜಸ್ಟ್ ಪ್ಲಸ್ R1 ಮಾಡಿದ್ರೆ ಸಾಕಷ್ಟೇ. 2 into B 2B ಪ್ಲಸ್ R1 ಅಂದ್ರೆ minus 2B 2 plus 2B ಏನಾಯ್ತು ಸೊ ಅದು 0 ಆಯ್ತು. ಸೊ ಹಾಗಾದ್ರೆ ಇದನ್ನ ನಾವು ಅಪ್ಲೈ ಮಾಡ್ಕೋಬಹುದು 0 ಮಾಡ್ಕೊಳ್ಳೋಕೆ ಡಿಟರ್ಮಿನೆಂಟ್ ಆಫ್ ಅದು R2 ಮಾತ್ರ. ಸೊ 0 minus 2C minus 2B R2 ಏನು 2R2 plus R1 ತಾನೆ 2 into B 2B plus 0 2B plus 0 ಎಷ್ಟು 2B. ನೆಕ್ಸ್ಟ್ 2 into C 2C R2 ಬಂದು 2 times of R2 ಬಂದು C plus A ಮತ್ತೆ ಪ್ಲಸ್ R1 ಅಂದ್ರೆ ಏನು minus 2C 2C plus 2A minus 2C plus 2C minus 2C ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತಲ್ವಾ ರಿಮೈನಿಂಗ್ ಏನು ಬಂದಿದೆ ಸೊ 2A. ಸೊ ದಿಸ್ ಈಸ್ 2A. ನೆಕ್ಸ್ಟ್ 2 into B 2B R1 ಅಂದ್ರೆ minus 2B 2B minus 2B ಏನಾಯ್ತು ಅದು ಮತ್ತೆ 0 ಆಯ್ತು. ಸೊ ನೆಕ್ಸ್ಟ್ ರಿಮೈನಿಂಗ್ C ಮತ್ತೆ A plus B ಆಯ್ತು ಕಡೆನಾ. ಸೊ ನಾರ್ಮಲ್ ಆಗಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀವಿ ಸಾಕು. ನಾವು ಏನು ಎಲಿಮೆಂಟ್ ಆಪರೇಷನ್ ಅಪ್ಲೈ ಮಾಡೋದು ಮತ್ತೆ ಇನ್ನೇನು ಚೇಂಜ್ ಏನಾಗಲ್ಲ. ಸೊ ಪ್ಲಸ್ ಮೈನಸ್ ಪ್ಲಸ್ ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಏನಾಯ್ತು ನಾವು 0 ಗೆ ನಾವು ಏನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ 0 ಆಯ್ತು. ಸೊ ನೆಕ್ಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಏನಾಯ್ತು minus into minus plus 2C na. For this you can leave that first row second column 2B into this one 2B into A plus B minus 0 into C ಏನಾಯ್ತು ಅದು 0 ಆಯಿತು. So for the 2C you can leave the first row second column 2B into A plus B ಆಯಿತು minus 0 ಆಯಿತು. Next plus into minus so second term minus 2B ಗೆ so ಏನಾಯ್ತು 2B into C 2BC ಆಯಿತು ಮತ್ತೆ 2A into C minus 2AC ಆಯಿತು. So next simplify ಮಾಡೋಣ ಅದನ್ನ. So ಇದು 0 ಆಯ್ತಲ್ವಾ? 2c into 2b 4bc 4bc into a 4abc 4bc into b 4b square c 2 into 2 4 b into c bc 4bc ಆಯ್ತಾ? ಇದು ಮಾತ್ರ 4bc ಆಯ್ತು. 4bc into a 4abc 4bc into b 4b square c. ನೆಕ್ಸ್ಟ್ ಇದು 0 into 1 0 ಆಗುತ್ತೆ ಬಿಟ್ಬಿಡೋಣ. ಓಕೆನಾ? ನೆಕ್ಸ್ಟ್ minus 2b into b minus into plus minus ಆಗುತ್ತೆ. 2b into 2b ಎಷ್ಟು ಆಯ್ತು? 4b square c ಆಯ್ತು. minus into minus is plus 2b into 2a ಎಷ್ಟು ಆಯ್ತು? 4 times of ac ಆಯ್ತು. So 2 into 4 times of abc ಆಯ್ತು. So 0 first row first column. So R2 changes to 2R2 plus R1 alva. 2 into B 2B plus 0. 2 into C 2C plus 2A minus 2C 2A ಆಯಿತು. 2B minus 2B ಅದು 0 ಆಯಿತು. Next CC A plus B. So ಒಂದು ಕೆಲಸ ಮಾಡಿ. So ಎಲಿಮೆಂಟರಿ ಆಪರೇಷನ್ ಅಪ್ಲೈ ಮಾಡಕ್ಕೆ ಹೋಗ್ಬೇಕು. ಸೊ ಅಲ್ಲಿ ಮಾಡಿದ್ರೆ ಮತ್ತೆ ನಮಗೆ ಲೆಂತಿ ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲೇನು ಅಪ್ಲೈ ಮಾಡಕ್ಕೆ ಹೋಗಬೇಡಿ. ಸೊ ಜಸ್ಟ್ ಇಲ್ಲಿ ಮಾತ್ರ ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಮಾಡಿ ಸಾಕು. ಸೊ ಪ್ಲಸ್ ಮೈನಸ್ ಪ್ಲಸ್ ಇಲ್ಲಿ ಮಾತ್ರ ಎಕ್ಸ್ಪ್ಯಾನ್ಷನ್ ಮಾಡೋದು ಸಾಕು. ಅಷ್ಟು ಬಿಟ್ರೆ ಏನಿಲ್ಲ ಅಲ್ಲಿ 0ಗೆ. ಸೊ ನಾವು 0ಗೆ ಏನ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡೋದು 0 ಅಲ್ವಾ? ನೆಕ್ಸ್ಟ್ ಮೈನಸ್ ಇಂಟು ಮೈನಸ್ ಏನಾಯ್ತು? ಸೊ ಪ್ಲಸ್ 2c ಆಯ್ತು. ಇದಕ್ಕೆ ಫಸ್ಟ್ ರೋ ಸೆಕೆಂಡ್ ಕಾಲಮ್ ಬಿಡಬೇಕು. b ಇಂಟು ಎ ಬಿ ಇಂಟು ಎ ಬಿ ಪ್ಲಸ್ b ಇಂಟು ಬಿ ಏನಾಯ್ತು? b ಸ್ಕ್ವೇರ್ ಆಯ್ತು. ನೆಕ್ಸ್ಟ್ ಮೈನಸ್ ಸೊ b ಇಂಟು ಸಿ ಏನಾಯ್ತು? bc ಆಯ್ತು. ಯಾವುದಕ್ಕೆ? ಫಾರ್ ಫಸ್ಟ್ ಸೆಕೆಂಡ್ ಎಲಿಮೆಂಟ್ಗೆ ಫಸ್ಟ್ ರೋ ಸೆಕೆಂಡ್ ಕಾಲಮ್ ಬಿಟ್ರೆ b into a plus b into a ba plus b into b is b square minus b into c b square. Next third element plus into minus 2b. ಇದಕ್ಕೆ ಏನು ಮಾಡಬೇಕು? you can leave the first row third column ಬಿಡಬೇಕು. b into c bc ಆಯ್ತು ಮೈನಸ್ ಇದರಿಂದ ಎರಡನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕು. c into c c square ಅಂದ್ರೆ minus c square c into a ac with minus ac ಕಡೆಗೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೊಳ್ತಾ ಸೊ ಇಸ್ ಬಿಟ್ಟಾಗ ನೋ ಪ್ರಾಬ್ಲಮ್. ಅದು 2c into ab 2abc 2c into b square 2b square c 2c into minus 2bc square minus 2b into bc minus 2b square c minus into minus plus 2bc square minus into minus plus 2 times of abc b into ac abc. So now plus 2b square c minus 2b square c minus 2bc square plus 2bc square cancel ಆಯ್ತು. 2ab plus 2abc ಎಷ್ಟಾಯ್ತು? it becomes 4 times of abc ಆಯ್ತು. So that should be the RHS. So okay, so ಇಲ್ಲಿಂದ ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳಿ ಸಾಕಷ್ಟೇ. ಮತ್ತೆ ಸುಮ್ಮನೆ ಹಾಕಿದ್ರೆ ಎಲಿಮೆಂಟರಿ ಆಪರೇಷನ್ ಅಂತ ಕಡ. So this is how you can do the problems based on the properties of determinants. So next class ಅಲ್ಲಿ ಇನ್ನೊಂದು 2 to 3 ಪ್ರಾಬ್ಲಮ್ಸ್ ಇದೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅದನ್ನು ಕಂಪ್ಲೀಟ್ ಮಾಡಿಬಿಟ್ಟು ಸೊ ನೆಕ್ಸ್ಟ್ ಏರಿಯಾಸ್ ಆಫ್ ಟ್ರಯಾಂಗಲ್ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ. ಆಲ್ ನೀವು 10th ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿರಲ್ಲ ಏರಿಯಾ ಆಫ್ ಟ್ರಯಾಂಗಲ್ 1/2 x1 into y2 minus y3 when you have the 3 vertices how you can find the area of a triangle. ಅದನ್ನ ನಾವು ಇಲ್ಲಿ ಡಿಟರ್ಮಿನೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಅದನ್ನ ಸಾಲ್ವ್ ಮಾಡ್ತೀವಿ. ಓಕೆನಾ? ಸೊ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಇದರ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಏರಿಯಾ ಆಫ್ ಟ್ರಯಾಂಗಲ್ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ. ಓಕೆ.